and I will talk about some use cases. If I have time left, I will talk about a few other points. First on the PMS, Pavement Management System. As a pavement manager, the thing you want to know is the quality of your road network. And you want to know that in one glance. So if you use a GS system and you look, we present here the IRI, International Roughness Index, the measure of quality of a road in color code in the GS. If the road is good, it's green. If it's so-so, it's yellow. And if the road is bad, it's presented in red or in black. So here you have an example of a red and black road. So let's zoom in. As a pavement manager, that's what I do. I zoom in more to that particular road that is in a bad condition. This is the road. Now I take a side jump and I tell you, if you do pavement management, it's important that you gather all the relevant information. And in a GS system you can do so. So here I add airplane pictures that surround the road that I have to reconstruct. And it's important to know how many people are living next to that road. So you can do the communication, and you can do the planning. It's also impacting your budget. So if I zoom in further to that particular road that is in bad condition, now I come to the digital model. So first I show you the results, the quality, which is calculated from the digital model. Here you see the geometrical digital model of that road. Now, because we don't have the time to turn it around, how to present a 3D model, we chose to present it in a color code. Follow me, the legend is green is flat road, blue and purple is lower level, so subsidence, so distress of the road, and yellow and red is a higher level. So a very good road will look completely green. That's a flat, good condition road. That will also have an IRI green. Here you see it's like a color book. There's a lot of bumps and subsidence, so that's the reason why the IRI was red or black. And even you see that there are some potholes. Some potholes, blue, some marks of blue, some things popping up. So you see the road is indeed bumpy, based on the color code of the geometry. So if we zoom in further, you see some potholes and some marks and some joints that are badly connected. And now I switch off the layer of the airplane pictures and I look at the geometrical model alone. The geometrical model is a 3D model of the road. And we add also camera information. So now you see where those potholes are. You don't see them on the picture, but you do see them on the 3D model. But you can have an imagination and you can have a representation of the visual, what we know best as human, and the 3D model. There are already now 5 dimensions. 2 dimensions for the camera images and 3 dimensions of the geometrical model. Another example is an example of rutting. On the picture here, you see that the road is used, and the stones are glancing, beaming, but you don't know if the road is really damaged. On the geometrical model, you see, and if I zoom in, you see it even better, you see that the tracks where the wheels are hitting the road have pushed down the road and damaged the road. Here you see even how to repair it, because there's the top layer of the foundation intelligence. And with artificial intelligence, you can extract all local distresses, like cracks, like potholes, like delamination, like even bleeding and ravening. Why is it important? If you have to plan and calculate your budget to repair, it's very important that I have that information. Why? Just cracks, how do you repair it? You fill it up with liquid asphalt. That's not expensive, that's pretty easy. Yeah? If you have delamination, you can put patches to repair it. It's pretty easy. If you have crocodile cracks, that's... pointer is not working. If you have crocodile cracks, that's more fundamental damage of the road. There you have to think of redoing the top layer of the foundation. If you have raveling is very easy. You clean it and then you put a slam layer over it and the road will survive another 10 years. So this information, detailed information together with the geometry is very important to plan and to budget the future expenses of road management. And those information of all those cracks, they're also geo-referenced. So if you upload those pictures, with artificial intelligence, you can extract all local distresses, like cracks, like potholes, like delamination, like even bleeding and raveling. Why is it important? If you have to plan and calculate your budget to repair, it's very important to have that information. Why? Just cracks, how do you repair it? You fill it up with liquid asphalt. That's not expensive, that's pretty easy. Yeah? If you have delamination, you can put patches to repair it. It's pretty easy. If you have crocodile cracks, that's... pointer is not working. If you have crocodile cracks, that's more fundamental damage of the road. There you have to think of redoing the top layer of the foundation. If you have raveling is very easy. You clean it and then you put a slam layer over it and the road will survive another 10 years. So this information, detailed information together with the geometry is very important to plan and to budget the future expenses of road management. And those information of all those cracks, they're also geo-referenced. So if you upload those pictures,
but you also have the location. So when you're sitting behind your computer, you will see where you have the most cracks. You will see where you have delamination. You will see where to do what kind of repair. And it's all important to have that, all that information, because it's scientifically proven that to repair cracks, for instance, it's not costly, but it's very important to take a long lifetime of your road. Yeah, so it's scientifically proven that many short repairs, yeah, you see the top of that graph, the blue, many short repairs are less costly than one big repair. So it's important to maintain regularly the condition of your roads. To save budget, that's the point. You do pavement management to save budget. With which technology can we collect all these models, all these 3D models? Today there is a LiDAR technology that allows you to digitize millimeter precise the road pavement. And if you have the full digital model, then you can extract and calculate profiles, and calculate IRI, crossfall, banking, and so on. So the LiDAR is this position. Now the white one, it gives you two 3D models, the geometrical 3D model and the reflectivity 3D model. And the reflectivity will show you where are the lane markings, the road markings on the road, painted or with stones. We have the camera next to it, that's the white small one, and all this data is geo-referenced with an RTK GNSS. So every data that is collected and stitched to the models is very accurately centimeter precise according to Google, centimeter precise geo-referenced, geo-localized. And that data you all imported in your GS. So you can do your pavement management behind your desk. You can measure one lane or you can measure two lanes at once. If you have multiple lanes, like on runways, we also measure runways, then you have to do different rides to collect and then to stitch all the data together. Here you see on the right, you see the 3D model. Remember the color code, green is flat, blue and purple is lower level, and yellow and red is higher level. And on the left you see the reflectivity model, how much the pavement is reflecting light, and so that shows you where there are road markings. Because the road markings are painted so we can see them better with our eyes, because it's reflecting more light. And as I said, when you have the 3D model, you can calculate any kind of measure. We are certified by NCAT and by RCART to correctly calculate out of the 3D model the IRI, the rutting, crossfall, and so on and so on. Rutting according to the standards, all to the ASTM standards. Some use cases. I'll go pretty quickly. One example of an intercity road where the government asked a contractor to replace some concrete slabs, individual concrete slabs. It was just before the previous elections in Belgium. They did the replacement, they checked it visually, and they said okay, and everything was paid. 1 month later, there was a lot of complaints coming in from people using the road and from the neighbors. Too much noise and very uncomfortable road. But the government said, yeah, okay, we measure the IRI, it's indeed too high, but why? They couldn't understand why, and the contractor said, but look at it, it's good quality, what's wrong? If you digitize it, you can see those grooves, those blue lines, lateral lines. So if you drive over, it's like a washboard. So of course it's making noise and is very discomfortable. But you also see how come the contractor immediately realized with those slabs, you pour the concrete and you're allowed, according to the contract, to flatten it manually with a ruler. But if the concrete is too dry, then the concrete will stick to the ruler and then loosen, stick and loosen. And this is causing these grooves. So you don't only understand why the IRI is bad, you also see how it came, and very often how to repair. That's why digital modeling is so important. Another example in a concrete slab road that was repaired partially on the left in 2022, and then just before the full renovation with variable milling, we did a measurement, and just after. I'll go pretty quickly, it's that road, but it's not so. And here you see the yellow curve is the measurement of the IRI in 2022. The blue one is after small repair. And then you see at the beginning of the road, the IRI went down, so it's improved. But in general, over time, you saw that it was degrading. The road was getting older. And a road in bad condition is damaged by the traffic that is running over it. So they chose, that government chose for variable milling. Instead of renewing a concrete slab road, that's very expensive, they said, no, we're not going to renew it, we're going to freeze it, we're going to mill it. With a machine, we mill it and make it flat again. And with the measurements that we did before, they can even control and design how the milling should be done. And the result is the green. So you see, we have a pretty cheap intervention, not a complete reconstruction, just variable milling. They improved the IRI up to below 4. And that's again, in your GIS, it will look green. So the road really passed from red to green with a pretty cheap, not expensive measure for repair. That's another example of a road where you had different conditions in the middle of the road, but I'm not going to go in detail. Here again, we discovered for the government in a dispute with a contractor what was wrong. And so the government said the IRI is not good enough, but the contractor told them, show with the ruler, with the legal measure, show me where it's not good. And the government could not tell them. They asked us to measure it. We have the full digital version, and here you see it's again those grooves. You see the blue grooves in the road, meaning that the road is really slightly going up and down. You don't see it on a picture, you don't see it visually, but if you drive over it at a certain speed, you feel it. And it's really annoying. So the government then took the ruler and knew exactly where to measure and show the contractor why the IRI was bad. So it's giving you insights. Just having a bad IRI is not enough to do pavement management. Another example where we showed, you see on the right corner next to the picture, the blue spot. It was a suspicious, large blue spot. We gave that information to the government, and they inspected, and what turned out, there was a leakage of the sewage underneath the road. So with measuring and digitizing the pavement, you can learn also what is happening underneath. As I told you, once you have the digital model, you can extract any kind of measure. This was a project for the US, where we calculated the banking in the turn of highway. There are some regulations on highways where you can have 55 miles per hour, that the banking should be between 2 and 3 degrees, so that the cars are not pushed out of the turn. And so this we can measure from that 3D model. All from your desk, because you measure it once, and then you can calculate any measure out of that. With the same technology, we also digitize runways of airports. Also, the AIRA is applicable for runways, internationally, everywhere. I just expand now, very quickly, that the same technology is used to measure the quality of bike lanes and sidewalks. More and more attention goes to bike lanes because the governments want people to use more bikes for the environmental reason, but also the sidewalks for safety and for accessibility. And this is then the outcome, the 3D model of a bike lane. And you see the spot, we also measure the 2D pictures, and it's all correlated with the georeferencing. And then when I talk about pavement management, the digital pavement management, you better, with the same drive, you can also digitize the environment and then do asset management of your trees, of your light poles, collect all the data in one drive. And I'll go quickly to some examples. This is a digital model of the environment with light poles, with houses, with every asset around the road. And we need some expertise, some consulting for a light pole company there. This is also to measure the electric cables above the trains that are giving the power to the trains. Or when you can pass a bridge. Also asset management. And that's with a SLAM LiDAR, 3D mobile mapping. So as a summary, pavement management is shifting today, it's not a future, to digital. You better collect all the information in one good GIS platform. And there's new technology available and easy to use to digitize all this information. And any street. And when you drive one to do data collection, you better prepare so you have all the data in once. If you want to know more, please visit us at the INFRAPLUS booth M9 here around the corner. Thank you.